So in this problem, we're asked to evaluate the square root of negative 36 and write it in complex form. Well, obviously, there is no real solution to the square root of 36. What number times itself would be negative 36? Well, 6 times 6 is 36, positive, and negative 6 times negative 6 is also positive 36. So that's why this one has an imaginary solution. With imaginary numbers, it's important to remember that I, imaginary number, is equivalent to the square root of negative 1. And then when we check our solution, remembering that I squared is equal to negative 1 will help. So what I like to do is think of the square root of negative 36 as broken into the square root of negative 1 times 36. And then using the product rule, we know we can break this into two separate radicals. So now we have the square root of negative 1, which is I, and the square root of 36, which is 6. Now normally we put the 6 first and then the I. So the solution is 6i. Let's check it. Is 6i times 6i negative 36? Well, 6 times 6 is 36, and I times I is I squared. But remember again that I squared is negative 1, so this is 36 times negative 1 is negative 36, sure enough. Now when you enter your answer in WAMAP, they want it in terms of A plus BI. Well, we don't have a real number part in our answer. Our answer is just 6i, so if I wanted to write that as a complex number, A would be 0, and then I'd have plus 6i. So A is 0, and then the coefficient on the imaginary part is 6.